Hello everyone, how are you all? So in this video we are going to cover again an important test called integral test, which we will be using to check whether a particular infinite series converges or diverges. So let's understand the theorem of this thing. The statement says if a series is given like this, an infinite series is given, and here an is considered to be a function fn. Generally we will not write the function f of n, we will write the function as f of x, we will replace the n with the x. Now, a very basic condition is that if this function follows the conditions like this, it has to be continuous in the interval from wherever it is starting. Like if it is starting from n is equal to 1 to infinity, so from 1 to infinity, the function should be continuous. Function should be positive, means the graph should lie above the x-axis. It is decreasing and defined for all values of x greater than or equal to 1. Although continuous and defined are the same thing over here, it is defined means it is always continuous. So these three conditions should met. It should be continuous, it should be positive, and it should be decreasing. If it follows these conditions, then this and this both will have same nature. So what we will do the improper integral of this function from 1 to infinity, the lower limit this and this, both of them has to be same. So if this improper integral converges, our series converge, or if this improper integral diverges, our series will diverge. So we have to solve this improper integral in all these things. So most important thing over here is when we are saying each term an, like in the series, when we are talking about the series over here, when n goes from 1 to infinity, so every term an forms a rectangle. And when we say the series, it means like a1 plus a2 plus a3, every term a1, a2, a3 forms a rectangle. So the sum of the series is basically equal to the sum of the areas of all the rectangles. And when we say the integral is basically the area under the curve. But when we are saying the function is decreasing, we have assumed that the function has to be decreasing, right? Then only we can apply this test. If the function is decreasing, then the rectangles approximate the area closely. So let's look at these graph. You can see this is a particular series given to us, an, and goes from 1 to n, and here this is also the same thing, and goes from 1 to infinity. Now in this case we have started the rectangles from the left side, like starting from the 1 itself. So you can see these rectangles are there, and this is the function. The function is decreasing, right? So in this case the area of the rectangle is more than the area under the curve. And when we have started from the right side, like we are taking the first rectangle at the point of 2, we have started, the height is at the 2. So in this case the area of the rectangle is less than the area under the curve because this much is left. So if our particular integral converges means it gives a finite answer, then the area of the rectangle will also be finite, and in that case we can say the series is converging. If the integral diverges, let's say the answer is coming out to be infinity, in that case the sum of the area will also be infinity. Sum of the area also infinity means the particular series diverges. That's what it is written over here. If finite area is there, then we will simply say convergent. If infinite area is there, we will simply say the series is divergent. That is why we have to make sure that the function has to be decreasing. Okay. So let us take some examples. Here it says determine the convergence or divergence of the series. So this is the series 1 upon n ln of n. So first of all we have to see that this particular function, this is the an, right? Here an is 1 upon n ln of n. Now we will say fx. We will replace the n with the x. So it is 1 upon x times ln x. This is the function. We have to make sure that the function should be positive. For now here x belongs to 2 to infinity. So in this interval the function has to be positive, continuous, and decreasing. So since x is positive over here, if you look at the graph of ln x, the graph of ln x looks like this. This is the 1 comma 0. So we can clearly see that at the 2 the value is positive. So for all the values greater than 2, the function ln x is positive and x is already positive. So we can say one thing, the function is positive, the complete function is positive. Second thing, is it continuous? X is a continuous function, ln x is a continuous function, so product of both of them will also be continuous. and then we have to see is it decreasing or not. Now here you can see as we increase the values of x, this value of x will increases, and if your ln x is an increasing function, so if you increase the values of x, the ln x will also increase. But since both of them are in the denominator, so denominator will keep on increasing as we increase the values of x, so complete fraction will decrease. So now we can say that this function is decreasing also. Sometimes you can take the help of the derivative also. With the help of derivative also you can check whether the function is increasing or decreasing. Just like if I want to check for this function, this fx is 1 upon x ln x. Suppose you are not getting directly, so you can do the derivative. If you do the derivative of this function, so let's say I'm applying the chain rule over here. So differentiation of this thing 1 upon something is minus 1 by x times ln x whole square, and then according to the chain rule, differentiation of x times ln x, differentiation of x times ln x, I am applying the product rule, differentiation of first function, second as it is, plus first as it is, and differentiation of second. So if you see, it is minus of ln x plus 1 whole divided by x ln x whole square. So denominator is already positive due to the square, and when we are putting ln x is already positive for greater than 2, so this bracket will always be positive, but due to the minus sign it is negative, so derivative is negative, therefore we can say the function is decreasing. So now we have satisfied the three conditions, positive, continuous and decreasing. So we can take the help of the integral. So 2 to infinity we will integrate. Okay, so we can integrate over here. Let us say integration from 2 to infinity 1 upon x ln x. Now how we can integrate this? Using the u substitution we can make. We can say, let's say ln x is equal to u. So if ln x is equal to u, so derivative is 1 upon x dx, that is equal to du. So dx upon x is given, so that will become du by u. And what will be the limit? Now right now the lower limit is 2, so ln of 2 will be, u will become ln of 2, and the upper limit is infinity, so ln of infinity is infinity. So this is the improper integral. So in the improper integral, what we do, we simply change the values. We can make the integral like this: 1 upon integration of 1 by u is ln of u, and here we put this, and let us say the upper limit I am putting as k, and I am putting the limit that k goes toward infinity, because upper limit is infinity, like that. Now if you solve this thing, so it will be ln of k minus ln of 2, and the limit goes, k goes toward infinity. When the k goes toward infinity, so ln of k will be infinity, infinity minus a very small number, that will still be infinity. So this is infinity over here. Infinity means that integral is diverging. So therefore we can say, since this function diverges, therefore our series also diverges. The series is 1 upon n ln n, from n is equal to 2 to infinity. This will also diverge. If the integral diverges, the series will also diverge. That's how we can use it. Let's take another example. Here it says whether the infinite series converges or diverges. So again we can say, what is an? An is 1 upon n square plus 1. So what is fx? Replace n with the x, 1 upon x square plus 1. Now I want to check it should be positive and continuous and decreasing. For the x is going from 1 to infinity. So this time x is going from 1 to infinity. So you can clearly see that this is x square. So x square will always be positive. Positive plus 1, that is always positive. So one thing is there, that this function is positive. Second thing, is it continuous? This is a rational function, so it is discontinuous only when the denominator is 0, but denominator can never be 0 over here because it is x square plus 1. No value of x can make it 0. So therefore we can say it is always continuous function. Second thing, is it decreasing? So again we can take the help of the derivative, but directly you can see the denominator keeps on increasing over here. Numerator is constant, but denominator will keep on increasing. So automatically it is decreasing also, or you can do the derivative also, that will be negative, so it is decreasing. So now we just have to do the integration. So therefore integration from 1 to infinity will do 1 upon x square plus 1 dx. So integration, this is the direct integration. 1 upon x square plus 1 is the derivative of tan inverse x. So integration is tan inverse x, and we will say 1 to, instead of infinity I will say k, and I will say limit k goes toward infinity. Now put the values over here, tan inverse k minus tan inverse of 1, and the limit goes from limit k goes toward infinity. If you look at the graph of tan inverse x, the graph of tan inverse x looks like this. This is the upper limit, this is the pi by 2, and this is the minus pi by 2 line, and the graph of tan inverse x is like this. So now you can see when the k goes toward infinity, when the input value is going toward infinity, when the input value is going toward infinity, the graph is approaching towards the horizontal asymptote of pi by 2. So it means this part will become pi by 2 only. And tan inverse of 1 we already know, it's pi by 4. So pi by 2 minus pi by 4 is pi by 4 we are getting. So pi by 4 is finite number we are getting. So therefore converges. So this particular series also converges, because we are getting an integral converges, so series also converges. I hope you have understood this thing. Now the important point after doing this question, it says the integral value is not equal to the sum of the series. In the previous question we were getting the integral value to be pi by 4, but that does not guarantee that the sum of the series will also be pi by 4. It is just the hint that the particular series will converge. So integral value of pi by 4 is not the sum of the series, remember this thing. Only use this test if the function is easy to integrate. Suppose if the function is very difficult to integrate, then we will not use this test. Then we can try some other test like comparison test or ratio test, whichever is applicable. And we have to make sure that the lower limit of the integral matches the starting n of the series. Like in this question you can see n was 1 over here, so integral was also starting from the 1. In the previous question you can see the n was 2, so our integral was also starting from 2. We have to make sure of this thing. Let us take one more. Here it is written we have to determine whether it converges or diverges. So again, what is an over here? An is given as n times e to the power of minus n square. So we can replace it by fx. So x times e to the power of minus x square. So basically we can write like this, x divided by e to the power of x square. So x is going from 1 to infinity. Now in this 1 to infinity, is it positive? So x is positive, so numerator is positive, and e to the power of something, e is an exponential function, that is always positive. So the both of them will be positive. Second thing, is it continuous? Because e to the power of x square is a continuous function. You know the graph, it's an increasing graph, and this is also an increasing graph, and both of them are positive. So, and this is never continuous. This x is also continuous and e power x square is also continuous. So both of them will be continuous because denominator is never equal to 0. Now third thing I have to check, is it decreasing or not? Now as you can see that the denominator will increase at a very faster rate as compared to the numerator. So it will be a decreasing function. But again we can check it by doing the differentiation. Fx is equal to x times e to the power of minus x square. To be 100% sure, just do the derivative. So I am applying the product rule, differentiation of first function, second as it is, plus first as it is. Now if I am differentiating the second function, it will be e to the power of minus x square. According to chain rule, it will be minus 2x. So we can take the e to the power of minus x square as common, and we will be left with 1 minus 2x square. Now when the f dash x, this part is positive, right? This part we know it's always positive. 1 minus 2x square. So what are the values of x we are having? X is greater than 1 to infinity. So if you put any value of x over here, and if you put 1 over here for x is equal to 1, this will become 1 minus 2 negative. If you put x as 2, this will become 1 minus 8, that is also negative. So this part will increase, and 1 minus greater number than 1 will always be a negative. So this is negative, so positive multiplied by negative is negative. So f dash x is negative, therefore 100% we can say it's a decreasing function. Now since it's a decreasing function, so we can go with the integral test now. So therefore we can say integration and 1 to infinity we can say, and the function we are having as x times e to the power minus x square. Now to integrate this thing, we can apply the u substitution. So let us do one thing. Let's take minus x square as u. So minus 2x dx, that is equal to du. Now what is the, we have to change the limits also. On changing the limits, if the lower limit is 1, so u will become minus 1. Upper limit is infinity, so it will be minus infinity square. Infinity square is only infinity, so minus infinity we can say. And the function will change like this. X times dx will become minus 1 by 2 du. So this is minus 1 by 2 du, and it is e to the power of u. This is the integral we have to solve. First of all, you can see the limit. It is going from minus 1 to infinity. So we have to swap the lower limit and upper limit. So it should go from minus infinity to minus 1. When we swap the limits, it becomes negative. So this is minus 1 by 2. So that will become positive and become minus infinity to minus 1 e to the power u du. So 1 by 2 minus infinity to minus 1 e to the power du. Integration we can write like this. Integration of this will be same as e to the power u. The lower limit is minus infinity and this is minus 1. So either you write minus infinity or you want to write something k also, you can do that. So if you put the upper limit, so e to the power of minus 1 minus e to the power of minus infinity. In place of u we are putting minus infinity. If you look at the graph of e power x, this is the graph of e power x. When we are going towards minus infinity, towards the left side, the graph is approaching towards 0. So it will be 1 upon e minus 0. So it is 1 upon 2e. So now you can see it is a finite thing we are getting. Therefore, since integral converges, so it will also converge. The series will also converge over here. I hope you have understood this thing. Okay. Now this is one question. This one I am giving for you to try this thing. Here one thing you will see that in this question ln n upon n, it is increasing for some time. For some duration it will increase in the starting, but eventually it will decrease. And we have to make sure that the function should eventually decrease. Sometimes you will see that the graph is increasing for some part and then eventually decreases. So we will apply the limit of integration from the point where it starts decreasing. Although it doesn't matter if you start from the 1 or you start from the number from which it starts decreasing, the answer will be same. But technically we should put the limit of the integration. The starting limit of the integration should be where from where the graph starts decreasing. So for when you will solve it, because it is not decreasing starting from the n is equal to 1, it will start decreasing after some values. So you have to check that thing from where it is decreasing. Use the concept of again the derivative and try to do this thing, and let's see whether it is converges or diverges. So comment below the answers for this question, what you got, whether it is converging or diverging. So I hope you have understood this part of integral test, how we are doing the questions. So if you have any doubt related to any question, connect with me on this WhatsApp. Thank you.